Hello everybody. In this mini lecture, I will finish up talking about chapter 2, displaying descriptive statistics. And just like in my previous presentation, I will briefly go through main definitions and quick examples, while actual construction using Excel is presented in different videos. In section 2.3, we're going to discuss various methods of displaying qualitative data. Let me remind you that this type of data is the one that can be split into categories. And here we have a couple of examples such as gender and level of education. And a lot of times we can think about these as proportions or percentages. Frequency distributions can help us display this kind of data by indicating the number of occurrences in all of the categories. And we have this useful function COUNTIF that's built into Excel that can be very helpful when determining frequencies for each of the categories in our sample. In this example, we're going to discuss this very useful function, COUNTIF. It is very helpful to apply it whenever you have a very big set of data and it's inconvenient to count values by hand. I'm going to go ahead and explain what the syntax here is. So on the left, in the left column A, we have all of these data that represent the grades. And you can see right here, the note says rows 8 through 29 are hidden. And the values for grades are A, B, C, D, and F. So that's in column C. And over here in column D, we're inputting our function. Okay, so we're telling Excel what to do. And let's just go ahead and take a look at the first row. It says equal count if, and in parentheses, we're putting some parameters here. So what is this A2 through A31? That refers to the set of data, right? So that's where our data is stored. So you would highlight your column that represents your data, and then comma, this parameter right here, C2, is what you're looking for to count. Now, C2, as you can see, is A, the letter grade A. So what this function is going to do, it's going to go through that set and count how many A's you have in there. Okay, and that's what's going to come up. Then relative frequency is going to take this value D2, divide by the grand total, which is the summation of all of the frequencies down here in D7. Okay, so that's how we find relative frequencies, the decimal values. And on the rightmost column, we have cumulative relative frequency, where we just add up all the frequency. And of course, over here on the bottom of the slide, you see the output. Okay, and it's always good to check that your frequency is indeed the total number of observations. Okay, in this case, we have 30 values. They start in cell number 2 and go all the way to 31. Relative frequencies over here, you can check that they add up to 1. And then cumulative relative frequency, the last cell in this column should be 1. Once we construct our frequency table, the next step is to create a graphical representation of this information. And I do that in my video. So here I'm going to briefly discuss the steps. Once you highlight your cells and your rows that you would like to display, you click on the graph tab over here, and you can see there is all sorts of different designs that you can select, and you can adjust the title, the axis, and so forth, and customize your graph to whatever you would like it to look like. This chart represents a couple of different designs for your bar charts. So on the top row, we have a horizontal bar chart on the left, and then on the right, we have exactly the same information represented in a vertical bar chart. Neither one is more correct than the other, so this is more of a preference. If you like horizontal bar charts, go with that. If you prefer vertical, then you can choose that one instead. Now on the bottom, we have two charts that we call clustered bar chart. That's the one that's on the left, or stacked bar charts. That's the one that's on the right. And these types of charts are used whenever we would like to compare information about two subjects. So for example, in this case, we're comparing different teams, right? And we're looking at their scores in 2 years, 2009 and 2010. Here's a quick example of displaying categorical data where we have a set of 20 observations that provides us different kinds of providers. So we have 4 providers. We count each provider and its frequency and put it in a table. So the total number is 20. We compute relative frequency as well, and you can check that the total sum of relative frequencies is 1. And once we display our data using a histogram, we can notice a couple of things. First, we notice that there are gaps between the bars. Whenever we're representing categorical data, we would like to keep those gaps. You do not need to worry about removing the gaps in this example. Also notice that we have the same width of our bars. However, the width of these bars is insignificant. You can make them as wide or as narrow as you would like, and it still presents exactly the same information. When we were constructing histograms for group data, that width was important. Okay, now notice how we also labeled all of our bars, and we can now determine which provider has the highest frequency. Now, you might be asking, which frequency should I use, the regular frequency or the relative frequency? And the answer is it doesn't matter. Okay, if you use the relative frequency to construct a histogram for this particular example, the only thing that's going to be different is the vertical axis representing percentages, right, or proportions. The shape of the histogram will be exactly the same. So once again, this is just a preference. Whichever one you prefer, that's the one that you should select. The next method of displaying information we're going to discuss is called Pareto charts. These charts are basically used to display information in decreasing order and identify the most problematic categories. So a lot of times in business statistics, these type of charts are used for quality control problems. And you can think about this method of displaying information as both a bar graph and a line, and they kind of display two different characteristics of your data. So let's go ahead and take a look at the example on the next chart. So let's take a look at this example. What do we have here? We have reasons for return of a product, and we have 5 categories: product defective, disappointed with product, product no longer wanted, late delivery of product, and other. And you can see on the right side that we have frequencies already ordered for us from highest to lowest. And product defective has the highest frequency of 46 numbers, right? So once we construct our chart, and there is an option for it where you just select Pareto, what's going to happen, you're going to get your bars organized in decreasing order. So the first category with the highest frequency will be displayed on the left, and then it just keeps going down as the numbers go down. Okay, why do we care about this method? This is done so we can easily identify problems that cause the most issues and target this particular category if we would like to see some improvements. Now, what is this red line? This red line represents cumulative relative frequency. So you can see that we start with 0.511, so that's 51% of all returns are related to product defective. Okay, and then we add the percentage for the next category, we get 0.756. So that's the total number of returns, a total percentage of returns whose reasons are product defective or disappointed with product and so forth. And you can see that once we add up all of our frequencies, we get exactly 1 or 100%. But from a business perspective, we would like to see this information for the reasons so that we can clearly see what are the categories that are most problematic and what needs to be targeted if we would like to see improvements. The next method of displaying categorical data is probably the most familiar to most students in the class, and it's pie charts. It is an excellent tool to compare proportions of the categories that we're dealing with, and we just need to keep a couple of rules in mind. All of the categories in the dataset need to be included in your graph. We use a pie chart to compare the relative sizes of your possible categories. So this is just a visual tool to see how your categories compare one to another. And bar charts in general are more useful when you want to highlight something important about your data. This slide shows you quick steps on what to do if you would like to create a pie chart in Excel. So once we have our table with categories and frequencies listed, we highlight the table, go to Insert tab, and you will be able to find that pie chart right there. You select the pie chart and you can click on either 2D pie or 3D pie. That's just your preference, and you can adjust the title, the legend, and so forth. If you would like to see a more detailed example worked out, I do have a separate video downloaded on Blackboard. Once we produce a pie chart, you can see that you may also select different designs. And again, there is no right or wrong answer here. This is just your preference, what you would like to see. Now, just be cautious as you create your graphs. Make sure that they are easy to read. All of the categories are labeled correctly, numbers are clear, and whoever is viewing that information is able to identify clearly without any trouble what is it that's presented in front of them. Here's another quick example of usefulness of pie charts, where we have a table that gives us information about the population in 2010, which is listed in thousands for 6 different continents. Now, if we just take a look at the table, it's very difficult to get this big picture of, okay, how big is each population relative to the rest. Now, if we take a look at the right, this pie chart tells us a really great story visually. We can clearly see that Asia has the largest proportion of the population, right? And we also have Oceania that has definitely the smallest. And it's just a nice visual tool to identify important information that's not so easy to detect just by looking at the numbers. We continue our discussion of displaying categorical data by looking at a very useful tool, contingency tables. These are the tables that provide us a platform of displaying data whenever we have two categories that we're interested in. And it's just a nice way to organize information if we're dealing with two qualitative variables. To better understand contingency tables, let's go ahead and take a look at the following example. Let's say we have a sample of customers at 7-Eleven that we've collected the following information. Gender, where we have two categories, female and male, and method of payment. And here we have three categories, cash, credit, and debit card. So a contingency table will have one of the variables displayed horizontally. In this case, it's the gender, and the other vertically. And for our example, it's the payment. And in the middle here, we input our frequencies that correspond to both of these characteristics. So for example, this number 7 that's highlighted, that represents the number of female customers that paid with a credit card in this sample of 20. Similarly, number 1 represents the number of male customers that paid with the debit card. And you can see that the numbers on the bottom represent the totals, right? We have 12 total female, 8 total male, which adds up to 20. And in the rightmost column, we have total numbers of customers that paid with each method, 7 for cash, 9 for credit, and 4 for debit. And of course, they also end up to 20. So this is what a contingency table is. On the bottom here, we continue to work with the contingency table, but now we rewrite all of our observations as proportions. And what do we do here? We divide our values by the total. Okay, so the total is 20. So 7 out of 20, that's your 0.35. That's the value goes here. And you can check real quick that all of these values, 0.1, 0.25, if we add them all up, we get 1. Okay, we can also talk about percentages of each category. So 60% of the sample was female, 40% of the sample was male. And then on this side, you can also determine percentages for the method of payment. So we will be dealing with contingency tables a lot. They're easy to construct, easy to display, and are very useful for displaying information in a very nice, concise manner. In the next few slides, we will discuss the steps that are needed to follow to construct a contingency table in Excel. Once you have your data in front of you, go ahead and click on any value within your data set. Then go ahead and choose Insert tab. And on the very left, you will see an option for Pivot Table. Click on Pivot Table, and in the drop-down menu, select Pivot Table. A Create Pivot Table dialog box will appear, and that's when we click OK. On the next step, you will see a new worksheet, and this is where we need to make a couple of decisions. So we need to drag the gender field down into the column labels, and you can see it shown right here with the red arrow, gender into columns, and then you drag the payment field down into the row labels. Now you could have done it the opposite way, gender into rows and payment into columns. Fundamentally, it doesn't really make any difference. So whichever your preference, that's fine. And then we drag the customer field down into the value box. So you will need to follow these steps to basically tell Excel how you want your table to look like. Once that's done, go ahead and press Update. And you will be able to left click anywhere within the pivot table, then right click on the cell you selected, and then you will see an option to select Summarize Data by Count. Once all of the steps are done, we will get a table that looks like this, and you can see that it's identical to the table that we've discussed a few slides back. Here we have gender represented horizontally, methods of payment represented vertically. We have our numbers inside the table, and we have totals for each of the categories. Now, I know we went through the steps of constructing this table pretty quickly, and please don't be alarmed if this is very new and challenging for you. In this particular class, we're not going to be constructing contingency tables. I just think it's important for you to know that this option is there in case something like that comes up at your job and you need to come up with the table on a fly, then you know where to look for help. However, in this class, we do need to be able to read information from contingency table, answer questions, extract important information, and eventually we will use contingency tables to answer some questions related to probability. The next method of displaying data that we're going to discuss is scatter plots. And just like with pie charts, most of you are probably familiar with this method as it is commonly discussed in introductory statistics classes and other mathematics courses. So a scatter plot is a method to represent relationship between two data points that come as a pair, where we have a dependent variable, and that's the variable that will be placed on the vertical axis. And we also have the independent variable that is typically put on the horizontal axis. So here's a quick example of a scatter plot that displays information about two characteristics of a product. We have the size of the television that's measured in inches, and that's our independent variable on the x-axis. And on the vertical axis, we have the dependent variable, price, measured in dollars. And you can see that there is some sort of trend going on as we have our size increasing, so does the price. Sort of, right? We have these vertical line segments that say, okay, we have a bunch of television sets that are of the same size. So we have 40 inches and maybe 48 and then maybe 52, but they vary in price. Okay, but here we could make a little bit deeper analysis, say, okay, what else is different about these products besides the size? Maybe it's the brand, maybe it's some other characteristics, but in general, it looks like the price does go up as the size increases. And on this slide, we will briefly discuss how to construct a scatter plot using Excel. I do have a separate video where I go over all the details of this construction. It is very, very simple. We highlight our columns. We have size as the independent variable, price as dependent. Notice that our observations do come in pairs. We cannot really mix them up, right? So the first observation, 43, that needs to be paired with 500. We go into the Insert tab and select this graph right here, Scatter, and you will be able to customize it with the title, labels, and so forth. The last method of presenting information that we're going to discuss in this mini lecture is line chart. Line chart is just a scatter plot in which the data points are connected, and we will use this type of graph whenever we're talking about some phenomena that's developing over a period of time. So for example, here you can see how we're observing Disney revenue over a period of time, looks like from 1993 roughly and up to 2010. So once again, a line chart is just a scatter plot where your data points are connected. Construction of line charts is done very similarly to what we've done with scatter plots. We highlight our columns. Year in this case is the independent variable and revenue is the dependent one. And then we go to Insert tab and select the following method. So this is scatter with smooth lines and markers. You select that option. Again, you want to make sure your title matches your problem and that all of the information is easy to read. You can select different designs. Just be cautious about how you customize it to make sure that your reader sees the information in a very clear way.